Hi everyone. Today we're going to learn how does the unit circle represent trig values. As you see, we have a circle here, and some of the most famous and important angles are marked on this unit circle. We call this circle as a unit circle because the radius of this circle is always equal to 1 unit. So if you have a unit circle, radius is always equal to 1. Now we're going to learn how does this unit circle represent trig values of the angles which are marked on the circle. Before that, let's go over the ratio of the sides on special right triangles that we know 30, 60, and 90. The ratio of the sides are x, x root 3, and 2x. Also, we have another special right triangle which is 45, 45, 90. The ratio of the sides on this triangle is x, x, and x root 2. Let's talk a little bit more about the unit circle. We have learned that if we have a point on unit circle, and if I draw a line from this point to the origin, the angle which is made using this line and the x-axis, let's call that theta. This point has coordinates like x and y. And cosine of theta will be equal to x, sine of theta will be equal to y. So we're going to keep this for now, and we'll refer back to this later. So for now, we know that if we have a point on the unit circle which has coordinates at x and y, x is cosine of this theta and y is sine of the theta. Now let's try to find this x and y. I'm going to draw a straight line from this point to the x-axis. So in this way, I have made a right triangle. The measure of this angle, as it's written here, is equal to 30 degrees. And of course, the other one will be equal to 60 degrees. If I find the value of x, that means the distance from the origin to this point, this is my x, and then the y value is the vertical distance from this point to the x-axis. So this one will be y. If I find these two, basically I have found sine of theta and cosine of theta. Okay, we know the ratio of the sides on special right triangle of 60, 30, 90. Opposite 30 is x, opposite 60 is x radical 3, and opposite 90 is 2x. But also we know that on a unit circle, radius is always equal to 1. So on this special right triangle, the hypotenuse is also radius of this circle. So this side is equal to 1. The side which is opposite 90 is equal to 1. So I'm going to write that here. Now I'm going to solve for x. If 2x is equal to 1, to solve for x, I'm going to divide both sides by 2. That means x is equal to 1 over 2. So this x is 1 over 2, and the other one, x radical 3, is going to be radical 3 times 1 over 2, which will be just radical 3 over 2. So we found the ratio of the sides on this triangle. Opposite 30 is 1 over 2, and opposite 60 is radical 3 over 2. And opposite 90, as we said, was 1, because that is the radius of this triangle. So I'm actually done. The x value represents the cosine of theta, radical 3 over 2, and the y value represents the sine of theta, or sine of 30 actually, is equal to 1 over 2. So I found these two x and y coordinates that they represent cosine of 30 and sine of 30. So that is how this unit circle can represent trig value of the angles. I'm going to try one more angle. This time let's try this one at 3 pi over 4. So the angle that I have here is this one. Starts from here and ends at this point. The measure of this angle is 3 pi over 4 or 135. Now, if I find the x and y of this point, x and y of this point, I have actually found sine and cosine of this angle, which is 135. We have learned before that the trig value of an angle is equal to the trig value of its reference angle. So if I find the trig value of the reference angle of this angle, I have actually found trig value of 135. Now, what is the reference angle of 135? The reference angle, as we know, is the distance between the terminal side and the x-axis. So it's this one. This is my reference angle. What is the measure of this reference angle? 180 minus 135. So the difference between 180 and the terminal side is going to be my reference angle, which is 45 degrees. Okay, now I'm going to draw a straight line from this point to the x-axis. Notice that the straight line is made with the x-axis, not with the y-axis. So this line is not the one that we're looking for, not this one. I'm going to make a line from the terminal side to the x-axis. So this will be my special right triangle, which is 45, 45, 90. The side which is opposite 90 and is my hypotenuse is also the radius of this circle. And we know that the radius is equal to 1. So this side is 1. Now I'm going back to the table that I had for 45, 45, 90. The side which is opposite 90 is equal to 1. Now we want to find the other two sides of that. X radical 2 is equal to 1. To find x, I'm going to divide both sides by root 2. So x will be 1 over radical 2. Now I need to rationalize this because we don't want any radical form in the denominator. So we multiply by radical 2. So the top is radical 2, bottom is radical 2 times radical 2 is 2. So the other two sides will be radical 2 over 2 and the same for the other one. Now these two sides are root 2 over 2 and root 2 over 2. Now I need to consider if I have any negative value here or not, because on the first one, the point that we have here is in the first quadrant, both x and y will be positive, but in the second quadrant, you know that the x value is negative. So this one is negative and the other one is positive, and we know that hypotenuse is always positive. So we're done. We found the x and y value because the horizontal distance between this point and the origin is called x, and the vertical between this point and the x-axis is y. So the point is negative radical 2 over 2 and radical 2 over 2. And what does this point represent? Actually, it represents sine and cosine, cosine of 45 and sine of basically cosine and sine of 135, because this is the angle that we are working. It also represents somehow 45, but right now we're working on 135, so I'm going to write that here. If I was working on the 45, which is here, I'm going to write that with green color. So this is going to be my triangle. So the ratio of the sides because this is 45, 45, and I know that the hypotenuse is 1. The other two sides will be radical 2 over 2 and radical 2 over 2. So the point here is radical 2 over 2 and radical 2 over 2. As you see, both of the values are positive. This is cosine of 45 and sine of 45. But this one is basically cosine of 135 and sine of 135. That's why we have a negative here. This is the difference between cosine of 135 and cosine of 45. We just used the reference angle to find this value, but we needed to consider the sines as well. Okay, now let's work on another one. I'm going to find coordinates of this point at 300. I'm going to erase all these to make some space for myself. Okay. So this time the angle that I'm working is this one. From here, this is our initial side, and then go back to this point. This will be my terminal side. Basically, this is my angle, which is 300 or 5 pi over 3. So if I find the x and value of this point, I have actually found sine and cosine of 300. Again, because this 300 is a big number, which is an obtuse angle, we cannot easily use a special right triangle to find the ratio of the sides. So we're going to use the reference angle here. The reference angle is the distance between the terminal side and the x-axis. So it's this one. This is my reference angle. Now I'm going to draw a straight line from terminal side to the x-axis. Notice, not to this one, only to the x-axis. So the line will be like this. And I'm going to have a special right triangle here. What are the angles here? If this is 360, we know that the whole circle is 360. And this is 300, so I subtract them. This angle will be 360 minus 300, and it's 60 degrees. And of course, this one will be 30 degrees. Now let's go to the ratio of the sides. We know that this special right triangle has a hypotenuse which is equal to 1, because this hypotenuse is radius of this unit circle. Now, the ratio of the sides, opposite 60 is root 3 over 2, and opposite 30 is 1 over 2. Now I'm going to write opposite 30, 1 over 2, 60, root 3 over 2. Now, do I have anything negative here? Yes, the y value here is negative because this is in the actually fourth quarter. And here y is negative. So we found x and y. X is 1 over 2 and y is negative radical 3 over 2. And this is cosine of 300, and this one is sine of 300. Okay, now let's talk about the angles which are on quadrant borders. The angles which are on quadrant borders are these ones. This one, this one, this one, and this one. These are on the quadrant borders. We know that this is 0, this one is 90, 180, 270, and 360. If I want to write them in radian, because all these are degrees, in radian they will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. To find the trig values of these angles, I don't need to make any special right triangle anymore. I just need to find the coordinates of these points. How do I find the coordinates of this point? We know that this is a unit circle. So on a unit circle, again, radius is equal to 1. So if I consider this point, the distance between this point and the origin is the x value. So the x value is actually 1 because this distance is the radius of this circle. So this is equal to 1. And what is y? It's 0 because if a point is located on the x-axis, the y value on x-axis is equal to 0. Now let's see what is this one. This one, x is 0 because any point on the y-axis has x value of 0, and the y value is 1 because this distance, the vertical distance between the point and the origin, is actually the radius of this circle. So it's 0 and 1. This point will be -1 and 0 because x is -1, is on the left side of the origin, and y is 0. This point, x is 0 again because it's on the y-axis, and y is -1 because it's below the x-axis. And we have also learned that sine of theta on a unit circle, if we have a point with coordinates x and y, sine of theta is x and cosine of theta is y. We also learned that in this case, tangent of theta is y over x. So if I have sine and cosine, I just divide y over x, and that will be tangent. Oh, I'm sorry, I made a mistake here. Sine is y and cosine is x. Then cosecant of theta is 1 over y. Secant of theta is 1 over x because this is reciprocal of cosine. And cotangent of theta is x over y. You need to memorize these. These are going to help you a lot to find values of trig functions. Okay, so let's do one example here. Cosine of 3 pi. I draw the coordinate plane here. We know that this is 0. The first thing to find cosine of 3 pi is to find the angle, draw the angle. 0, and here it will be pi. So if I make half a circle, I have pi radian. Then if I continue to make the whole circle, then I'm going to reach to 2 pi radian. But I need 3 pi, so I'm going to go another half and reach to this point. This will be 3 pi. So my angle is actually this. Starts from here and ends at this point. So if I know the coordinate of this point, I can find cosine of 3 pi. Coordinate of this point, based on what we did here, is -1 and 0. So this is -1, -1, and 0. And we learned that x is cosine of theta and y is sine of theta. So cosine is just the x value. It's -1. Now let's do the other one. Tangent of 3 pi over 2. This is 0. This is pi over 2, pi, and 3 pi over 2. So to draw the angle, I'm going to start from here and stop at this point. This is 3 pi over 2. Start here and ends here. So the angle that I have is a quadrant border angle. To find the trig value of this, I just need to find the coordinate of this point, which is 0 and -1. So we know this one is x and y. This is cosine of 3 pi over 2, and this one is sine of 3 pi over 2. To find tangent, we know that we have to divide y by x. So I'm going to do that here. Divide y by x. The y value is -1 and x is 0. So if you divide them, -1 divided by 0 is undefined. So tangent of 3 pi over 2 is undefined. So this is how you find the exact value of different trig function of different angles on unit circle. Have a good day.